Hello, Stan. Bear with me. We're not at the start yet. I'm just trying to get things set up. It's the first time I've ever done one of these, and well, that's fine. That choppiness you heard is because I was using machine 8, or was using the ZIF machine. The ZIF machine, if you've watched any of the other parts of the Repairathon, I found out that the ZIF machine is actually a PAL machine. It's not an NTSC machine. I need to convert it. Um, a an NTSC VIC-2 will work in a PAL machine, but it leaves parts of the machine is PAL, parts of the machine is NTSC, and because the sound is actually runs at a different frequency in PAL, um, that choppiness is because the PAL is trying to run at NTSC speeds, and it's wonky, which is why I just brought up this other machine to make sure that the audio was working. As you heard, it worked when I hooked this one up. So I'm just going to have to make sure that if I show anything during this using the ZIF machine, that I make sure to let people know that the ZIF machine sound will be wonky, and it's not broken. It's just um, running at the wrong frequency. So this machine proved that the audio and video input is working. That's what I was testing. Wanted to make sure that everything was good there. Like I said, I've never done one of these live before, so I'm not entirely confident in everything that I'm doing. So there it is. So we've actually got about a half hour till the live actually begins. I appreciate you folks joining early, but I want to wait till actually 2 o'clock for anybody else who wants to join. Come on. Another 15 minutes, folks, and we'll get started. Hello, 3V. No, I was testing out. Stan's been on for a while. I was testing out my capture device using a different machine, using the ZIF machine, and it because it's at the moment it's kind of a hybrid between a NTSC and PAL. The audio on it stutters when it's coming through the video capture device. When it's uh, going directly to my little LCD monitor, it doesn't have a problem with the audio, but through the capture device, it stutters. And that's what Stan heard. Once we get started with the live here at 2 o'clock, I will show you guys what the symptoms are for this machine. Um, this is actually one of the machines from the Repairathon that, and I'll explain this again when 2 o'clock rolls around. But I don't actually have any broken Commodore 64s at the moment. So what I did for this live is I took one of the machines that I've already repaired from the Repairathon, the number 4 machine, and I actually introduced some problems to it so that we could do the diagnosis together. So it's not going to be I guess it may not be quote indicative quote of a true repair because I've actually created the problems, but it'll let us all walk through some diagnostics. You guys will suggest to me what I should do at each stage, and we'll get this machine back up and running. I picked the number 4 machine because that's the one that I ended up putting a socket in almost everywhere. So it made it easiest to introduce problems into, and also the presence or absence of sockets won't give you guys any clues as to where the problem might lie, since the sockets are everywhere. Any clues as to what's wrong with your 2600? Yeah, well, you'll get nothing but sympathy from me on that. I know I've made my own fair share of screw ups, particularly along the way in this repairathon. Um, I It sounds like there's a pretty good chance that none of your ICs are screwed up. Though that would be a big problem since those can be hard to come by, particularly that TIA chip. Um, and I know it is hard to get good video out of those things. Um, I've done basically uh, the future was 8-bit composite mod on one of mine, and then I did. There's a service bulletin from way back in the 70s talking about how you can improve your video quality a bit by putting in an 820 ohm resistor, 820 or 820K, I forget which, resistor between two pins on the TIA. I actually have a video on that if you haven't seen it. Um, that boosted the signal level a bit, got me a brighter color level out of it. Hello, Rudy. But it is a pain. I mean, there's the new Clear Comp mod that's out for the Atari. It's a little daughter board that you solder to the back of the main PCB, attached to several pins of the TIA. And a couple of my friends have been looking at that, Captain Commodore and mostly Neil Retro for You. Um, you might check out their videos on the subject. Maybe that could help you get a better picture. But as for to finding where you might have you might have made a boo boo, I can't help you there. You're gonna have to trace it out yourself. We've got about 8 minutes to go until the top of the hour, and we'll get started. Well, Rudy, what we're going to do is we're going to um, try to repair a Commodore 64. It's actually one of the ones from the recent repairathon that I have added faults into. It was working at the end of the repairathon, and I just don't have any currently non-working C64s that we could work on, so I had to create one. And the reason just so you know, the reason I'm doing a live today, I had some plans for some content to release today, but things happened. I was waiting for some parts. I had another one that I needed to do further research on before I could move forward. So I ended up without content and decided to do this live. I had been considering doing one like this anyway, so I'm just sort of jumping the gun and doing it today. About 5 more minutes, guys. You're not kidding, Rudy. Yeah, that's always the thing. I think automotive technicians would tell you the same thing. But yeah, waiting on parts. Yeah, I get some of my stuff from AliExpress. You just you have to take into account the fact that you're going to get some either bad or I don't want to make any accusations, but either bad or not so genuine parts when you order from them. And obviously, coming from China, there is going to be a shipping time. I have honestly, though, been rather impressed. Getting stuff from China within a couple of weeks' time. I was surprised when I started ordering from them at how short the time is at times. Hello, Joseph. I haven't had anything take quite that long. 3V 6 to 8 weeks from AliExpress. It's usually on the order of two, maybe 2.5 weeks that I've experienced. Obviously, maybe some of the stores on AliExpress take longer. I know they're a lot like Amazon in that they have other vendors that sell through them. And yeah, as for the counterfeit, you take your chances with AliExpress. I've gotten some good deals through them, and I've gotten some bad ones. On the plus side, usually though, when I've had a problem, when I've had a counterfeit part come in, as long as I can show them evidence of it, which I usually do by making a video, they're quick to refund the money. So at least there's that. Yeah, it is becoming a bigger problem. I'm just wondering about the logic behind some of them. I've seen, uh, for instance, I remember Noel of Noel's Retro Lab running across some not so much fake, but relabeled 74HC logic chips labeled as 74LSs. Uh, I gotta wonder where's the profit motive in that. I mean, you're talking about chips that cost a buck or two. They're not making much money doing that. obviously with with some of the chips like the ones we are all familiar with, the Commodore MOS chips, in particular the SID, the VIC-2, um, there's a good profit margin in faking those because they're selling for a lot of money right now. But I just don't understand the ones that fake the little logic chips. And thanks, Rudy, for the compliment on the Timex Sinclair videos. I'm learning all about that machine. I remember them, I remember them being around when I was a kid, but I never had one. And it's interesting. I never knew up until recently that they were um, basically the same machine as the ZX81 out of Britain. I knew there was some kind of partnership with a British company, but I didn't realize how closely they were related to each other. Okay, well, we've gone past 2 o'clock, so let's go ahead and get started. Just so you know, guys, I think I'm seeing your comments pretty much immediately, but there is apparently a delay between, uh, you know, what I say or what I do and when you see it. So if you make a comment and you don't get a response from me for a few seconds, don't be surprised. It's that delay going on. So what we've got in front of us today is we have a Commodore 64. Let me give you a better view here. I can get the mouse to work. So, okay, this is, as you can see, it's machine 4 from the Repairathon. And if you watch the Repairathon, you'll remember we did get this machine working. It was a huge pain to get it working. And as a result, I ended up socketing almost everything on the board. Before I finally found the last problems with it, which were in the 257s here. So, being that it was fully socketed, I thought it would make a good machine to work on today. I don't actually have any, currently have any broken C64s to work on. So, what I did was I went ahead and introduced some faults, some faults into this machine. It could be 1, it could be 5. But I intentionally made this machine broken so that we could work on it together today. Um, it was ideal for that because of the sockets, because it was easy for me to swap things out and it'll be easy for us to diagnose. Also, because with everything socketed, you won't get any hints as to what's broken by seeing, what's in sockets and what was directly soldered to the board. Obviously, it would make no sense for me to solder in bad components, but slipping bad components into sockets is no big deal. So let's go ahead and bring up the output. Stupid mouse. Sorry, my capture machine is not the best, and as a result, when it's doing this streaming, it runs a bit slowly, and it's having trouble capturing the mouse activity. Come on. Ah. Come on. Being very stubborn right now. Come on, there we go. And all of a sudden, it just starts working. All right. Now you should be able to see what's going to happen when I turn this machine on. Now, we are hooked into my bench power supply, which you can't see off the back corner there. That my bench power, it's not a bench power supply in the sense that you'd normally think, but it's a bench Commodore power supply. It's connected here, and it's providing 5 volts through a switching power supply internally, plus the 9 volts direct from a transformer. So it's safer than using one of the old power bricks. when I switch the machine on, I'm seeing on the power supply, I've got an ammeter, so I'm seeing 0.66 or 0.67 amps draw on the 5-volt line, which is a little low if you recognize. And as you can see, there is no signal in the on the HD capture, so we're not getting a signal out of this machine. So that being said, where should we go first? 3V says check power. Oh, yeah, keyboard and case are missing. Right. Okay, so since 3V said check power, I'm going to do that. We will start with our voltage regulators. And if you all remember, we check first, we check the right-hand pin for the voltage output. Forgot, I need to play with the mouse again. Let you see my multimeter. Come on, wake up. There we go. So here's the multimeter, and we are set to DC volts. And on the 5-volt regulator, we have nothing. And on the 12-volt regulator, we have almost nothing. So I'm going to check that comes off of the 9 volts. I'm going to check the 5 volts by checking on these chips over here. So on the CPU, power is on pin 6. So I'll check there. And I am getting 4.87 volts. So the 5 volts is getting through. I'll go ahead and check up here on the user port. We're getting 4.86 volts on the user port. And sorry, we are getting basically nothing on the AC on the user port. So check for a short between 5 volt and ground. Well, like I said, on the 5 volts from the power supply, one, two, three, four, five, 6, and ground. Nope, we have open. So there's no short between 5 volts and ground. I would check clock, but I think we need to fix power first. Oh, with power off? Okay. 1, 2, 3, 4, 5, 6, and ground. And we're at 390 ohms, 400 ohms, so that is not a short. The power switch, yes, we could check the power switch. It should be shorted between these 2 pins when it's off, and it is, and nothing would open between these 2 pins when it's off, and shorted between these 2 pins when it's off. Oh, sorry, off. Okay, and not shorted between these 2 pins. Yeah. I'm working on this backward from the wrong side of the switch. Let's see. There we go. So that's open. And then when it's on, these should be open and these should be shorted. and they are. And these should be open. They are. And these should be shorted, and they are. So the switch is working. Now let's check. I want to check ohms real quick and make sure there's not a resistance in there that shouldn't be. So we're getting in the on position. Come on. In the on position, we are getting less than 2 ohms, so that should be fine. And in the on position, we're getting less than 2 ohms, so that should be fine. So our power switch is good. Check the fuse. You have identified problem number 1. So, yes, the fuse is bad. So, let me pop that out. Grab the replacement. And now, what happens when we apply power? Go back to checking DC voltage, turn the machine on. Well, the first thing you should see is that the screen has gone from no signal to black, so that's an improvement. And when I check the voltage on the 5-volt regulator, I'm getting 4.98, which is great. And on the 12-volt regulator, 12.14, which is also great. So, congratulations, you got it as far as being powered. So we should still have power, our 5-volt power. I'll check that again. 3, 4, 5, 6. Yep, we've still got our 5 volts. Now, that is a tad on the low side. So there may still, there's obviously still more problems with the board, but one of them may be a short in one of the ICs. Remembering, of course, that I didn't desolder anything to make these problems arise. It's not likely to be a short on any of the caps because I would have had to put in a bad cap to do that. I thought the caps were all good at the end of the repairathon video. So, clock, you're right. Next thing is clock. So, clock is on pin 1 of the CPU. And we are getting, let me get a measurement. Oh, sorry. Let me get a measurement here. Oh. If I could stay on the pin, that'd be good. We're getting 22.73 kilohertz. That's not right. And I'll be honest with you, I wasn't expecting that. Based on what I did to this machine, the clock should actually be correct. So let me check. And we need to. I actually think this might be a problem with the scope. Grounding somewhere else. Because there's no way my 14 megahertz crystal is providing 300 kilohertz output. I'm a little confused, I'll be honest with you. That's good. Someone suggested checking reset. Let's take a look at that real quick. I need to... reset is showing high. And when I switch it off and back on, it should stay low for a brief moment and then go high. And it does. So reset is looking good. And what we're getting on the screen has changed. Now we're getting garbage on the screen. That's interesting. I hope that actually doesn't mean what I think it means, because I don't remember making... Oh, hang on. What I'm about to check should not be the problem. But, yeah. That's not one of the supposedly bad chips. Looking at the VIC-ii, obviously. It should be a working VIC-ii. I don't think I even changed it. It's the one that was in it when we had the machine repaired and working at the end of the repairathon video. Okay, I'm back to a black screen again. So let's check the clock signal one more time. Ah, there we go. I had my meter set wrong. So we actually are getting a 1.02 megahertz clock, which is correct for the C64. And if we look down here at the crystal now, and time. Yeah, we're getting a 14 megahertz clock off the, or oscillation off the crystal. So the clock is actually good. The clock's good, the reset's good. Okay, so we have good clock and good reset, yet we still have black screen. So what would you guys suggest we look at next? VIC and PLA. All right. Well, to do that, I can pull both the VIC and the PLA. And test them both in the ZIF machine. If I can find the ZIF machine, where did I put it? There it is. Okay, we're all familiar with the ZIF machine. It's a machine that I installed 0 insertion force sockets on so that I could easily test parts. Oops. So let's turn it on and make sure that it comes up, and it does. Sorry, my RetroTink takes a moment to get the signal through. So when I said it does, and it still was blank, it was actually showing good on my little LCD. So let's first test the VIC. We're going to test them one at a time, because putting them both in at the same time, if they were both, even if just one of them was a problem, wouldn't tell us which one it was. So we'll try the VIC-2 first. And the VIC-2 works. So we've got a good VIC-2. And now we check everybody's favorite IC, the PLA. And we all know that these are almost always bad. But here we go. Would you look at that? We have a working PLA. Well, it's a good guess. It's always a good guess. This time, that wasn't the problem. So, PLA and VIC are good. What's the next thing we should check? The socket of the VIC chip. Okay. Well, it is an old socket that Commodore put in. Apart from checking every pin, which would be kind of difficult, I'm not sure how to check that. Let's just say for a moment that I checked it and that it's fine. And let's say that because the VIC isn't the VIC is not one of the problems that I introduced. So just to save the effort of getting little chip legs and testing all these things, which would take us a while and not be very productive, I'll just tell you that isn't the problem. Dead test. Okay, we can do dead test. On, off, off, on. Okay, this should be the updated STID version of the dead test. Oh, yeah, almost did. I do that all the time. Forget to move the VersaCart jumpers from ROM low to ROM high when I'm going into dead test. I've caused myself all kinds of problems with that. Well, let's see if we get anything. That actually seems to be worse. Oh, help us if I plug in the video. Okay, now let's see if we got anything. Really? Still nothing? What's going on here? We should at least be getting black screen because that's what we were getting before. Oh. How many of you saw that? Now let's try. We should get black screen here. Okay. Now let's try the dead test. I apologize for that, guys. I'm losing my mind. All right, this is again the STID modified version dead test. Okay, we're getting 4 flashes. So anybody know off the top of their head what 4 flashes, which chip 4 flashes indicates? Or am I going to have to look up the manual? Let's see if I can pull up. Okay, as you can see, according to the dead test manual, 4 flashes is U23. U23, I can't see. U21, 22, 23. So, dead test is telling us we have a bad U23. Well, you're right, 3V. It can be other things. It's often the PLA, but we've already tested that, so the PLA should not be the issue. Let me get rid of that diagnostic manual here. Oh, come on. So if it's not the PLA, it could either actually be the RAM chip, or it could be some of this logic in here. I think, though, because we do have sockets for everything, it's probably not a bad idea just to go ahead and check the RAM chip itself, since that would be an easy fix. So we will again grab our ZIF board. Make sure it's still working. And it is. And we'll go ahead and test this RAM chip. Make sure we've got the notch in the right direction. And see if anything happens. Black screen. So it looks like that RAM chip may be bad. Let me go ahead and grab my bin of 4164s and find one that's good. I have learned not to trust all of these that I bought. Some of them have been bad on me, so I always test them now before I try to use them. Let's check this one. And this one's good. Okay, so we can replace the RAM chip on our main board, the dead one, which is this, with this replacement, and that's the one that goes in the ZIF. So here's our board under test again, and this time you see me plugging in the power and the video, so I do try to learn from my mistakes. Yeah. And this is the new replacement RAM chip. That socket took a little damage. Let me fix that real quick. There. Now let's see what dead test tells us. Well, we're not getting flashing. We're actually getting to part of the dead test. Okay, well, the memory seems to be okay, but there's still something wrong. I need to read your guys' comments again. I kind of been distracted. So let's see what you've been saying. No, 3V, it's not MOSRAM that's usually bad. It's MT. That's Micron Technologies. That's not part of Commodore. Yeah, Midoff. Like I said, I might have introduced more than one or two problems. I didn't want this video to end so quickly after all, but we can get there. So, where would you guys go from here? Well, all the chips on the ZIF-60, all the major ICs on the ZIF-64 are socketed, and of course all the chips on here are socketed, so we can go anywhere. Color chip. So the color RAM, you think? To a bar, yeah. That would be a good place to go. I can't argue with you there. Yeah, oddly, the color RAM is not actually socketed on the ZIF machine, and the reason for that, if you notice, is it's kind of too close to the SID socket. I wouldn't have been able to fit a ZIF socket in there. So if we want to test the color RAM, I can take it out, and I do have this. The color RAM, as you know, is a 2114 SRAM chip, and this is an Arduino-based 2114 SRAM tester. So I can take out the 2114, and I can test it here. Oh. I just need to get it some power. I will borrow the USB from the not that, the extension. I borrow the USB from the bench cam that points at the scope. So we should have power now. Make sure that's seated better. And we'll go ahead and give this a test. Nope, the color RAM is good. It's bad at fitting back into its socket, but it's a good chip. Okay, there we go. Alrighty then. So, do you guys want me to go ahead and pull the ROMs and the CIAs if you're saying the dead test doesn't actually depend on them, which you're right, it doesn't. They can cause bus conflicts if they're in while the dead test is running, but the dead test doesn't actually use anything that's on them, and it doesn't actually use the CIAs apart from it will show the time of day clocks if they're available. So you want me to go ahead and pull all of these ICs? So we're just down to CPU, PLA, and VIC-2. And should I also pull the SID because it's not used by the dead test? Turn on the 64 without the dead test. Okay. Here's what we get without dead test. It is garbage. Now, one thing we can do is we could go ahead and look at Ray Carlson's pictorial fault guide. And yes, I did say the PLA is good. We pulled that out and tested it in the ZIF machine, and it worked fine. Careful with a SID chip, I agree. Okay, so seems like we're getting some agreement that we should pull the CIAs, the 3 ROMs, and the SID, of course being very careful with the SID. In fact, I will go the extra step, and I meant to do this earlier, I'm sorry. I will go ahead and put on my anti-static wrist strap before I pull the SID. So, here we go. Oh, this is actually a better way to pull. If you have one of these, for these larger ICs, this is a much better way to pull them. Pulls them straight up out of the sockets. It minimizes the stress on the board and on the socket and on the IC. So I'm going to use this to pull the SID. And the ROMs. And the CIAs. Okay, now, obviously it won't do anything without the ROMs, without the dead test cartridge. It would work if the CIAs were the only ones out and the ROMs were still in. I could run it without the dead test cartridge, but since the ROMs are out, I have to put in dead test to do anything. So let's see what we get on dead test now. Well, we're still getting partial response and then garbage. So, while some of those may or may not have been problems, they're not the only problem. There's still something else. So, of what we've got on the board, we've tested the PLA, we've tested the VIC-ii, they're both good. The RAM seems to be working now, but we're not sure of that until we can get a completed run of dead test. We're not 100% sure of that. So we have not tested the CPU, we have not fully tested the RAM, and we haven't tested any of the logic ICs. Now there is, just so you guys know, I know you can't see it from where the camera is. I'll bring this up here and show you. We do have one MOS branded logic IC. So, what's next? Well, the red color in the border is actually normal for the STID dead test. There's an updated version of the dead test called STID, S-T-I-D, and that's the one I'm running. If I were to switch it over, let me show you real quick. I will switch it back to the normal dead test. On. This will be normal dead test, and it should have the blue border. Whoa. Okay, on normal dead test, now we're getting flashing. That wasn't happening before. We're getting one flash. So we either have a problem with the RAM or we have a problem with one of the logic ICs that's causing that one flash. Check CPU address and data lines. Can do. Let Let me get a little extension cord for my ground, so I'm not always tied so close. All right, so the data lines start at pin 37 and go down to pin 29. I know 20 to pin 30. Sorry, 37 down to 30. So the data lines are, and let me make sure you're seeing this. Yeah. I need to plug this camera back in. There we go. Sorry, I had used that USB for the 2114 tester. All right, here is 48. Here is data 0. See channel. There we go. So that is, let me show peak to peak. That's actually kind of high. According to this, that's running up to over 6 volts. That's interesting. I've never seen that before. There's data 1, also running over 6 volts. Data 2, data 3. I'm not seeing any little half signals or partial signals. I'm just seeing over voltages. Next data line. That's 4. That's 5. That's a better representation. That's 6. And that's data 7. So again, 0, 1, 2, 3, and I can see where that over voltage is coming from ringing. If you notice, like right there at the top of that upward transition, you can see that ringing is taking it up to the 6 volt range, but the actual signal itself is sitting at 5 volts, so that's actually fine. Zero, 1, 2, 3, 4, 5, 6, and 7. So you guys tell me, but it looks to me like those are relatively normal. So let's start looking at the addresses. And the address lines start at pin 7. 1, 2, 3, 4, 5, 6. There is address 0. Those look relatively normal, strong enough to work. Address 1. Now there are some weird midway signals in address line 1. 2. 2 looks mostly normal. 3. There's some halfway signals in 3. 4. 5. 6. 6 is apparently either high or low. There's nothing in between. 7, mostly high, or all high. 8. 9 seems to be all high. 10. 11. 12. 13. 14. And 15. So, you've seen them. The data lines look relatively normal, but the address lines do not. So, let me see what you guys have been saying. Uh, 3V, yes, you're right. When the chips have been in for a long period of time and have sort of, you can almost consider it oxidized themselves into place, yes, it can sometimes be better to use a levering chip puller, such as this one from vic-ii. Um, you you can, but it's really not recommended to use a flat blade screwdriver because these have this angle to them, which makes it easier, this curvature that makes it easier to pull them. This is actually designed obviously for chip pulling. So yes, if they've been in there for a long time, you're quite right that that a chip puller like this is not the right tool. Something more like this would work better. Let's see. What happens if I use the Jupiter Lander cartridge? Well, without the ROMs in, nothing's going to happen. I do have Jupiter Lander as one of the banks on the diagnostics cartridge, but like I said, without the ROMs in there, it's not going to do anything, I don't think. Well, Midolf, you can knock on my front door. You could, if you want to get in touch with me about some of your broken boards, you're welcome to do so, and maybe we can work something out. But I think you probably got what it takes to do this yourself. You may not have the same tools or the tools, but you can figure it out. And 3V, wonder if the halfway signals aren't the other LS logic floating. I'd check schematic and see where those pins go. Well, they go lots of places. Yeah, you can't pull the small chips with these. It doesn't close far enough. So yeah, you kind of got to go with the vic-ii lifter or something like that when you're working with these smaller uh, form factor chips. It's really best for the big 24, 28, 40 pin packages, um, and it's obviously built for the wider chips. I think you're probably on the right track, 3V, with the LS Logic. I'm wondering if there isn't anything that might point you to one particular LS logic chip over the others. Moss branded. Well, Rudy, the signals on the CPU that we saw, the data lines looked relatively normal. Quite a few of the address lines did not. There were some cases where we were seeing little half signals that might or might not be strong enough to drive the bus, and other other pins were showing steady highs, which obviously shouldn't be quite right. We were discussing where to go from that, and I think it was 3V was suggesting that that we might have an issue with some of the LS logic, um, which is a very good thought at this point, because we did find one bad RAM chip, verified that it was bad, and replaced it. So my inclination is to think that the RAM itself is actually probably good. It could still be an issue, but we're most likely to find our issue in the logic. So do we want to start testing signals on the logic chips, or do you think we might have a particular candidate? Okay. So Rudy, you think we should pull the CPU and test it on the ZIF board? That's not a bad idea. So let me go ahead and do that for you. You're obviously not seeing me have much trouble pulling any of these ICs because again, that board was freshly socketed just a few weeks ago, so they haven't had time to to oxidize and just get stuck in the sockets. Now let's pop out our CPU here, pop in our CPU from the test board, power, video, and see what we get with this CPU. Now we don't have a dead test cartridge in, so we're just looking for basic. Okay, it looks like our CPU is good. We've got a good basic. We got the right number of bytes of RAM, and we got the flashing cursor and everything. So the CPU is not the issue. Now, while we've got the ZIF machine up here, you also said to pull and replace the MOS branded logic chip. Now that is a MOS 7709. And without going online to look for the equivalent, I'll just look on the ZIF board here in the same position, because they are the same board revision. They are both, they're both 250407s. The one we're working on is a Rev C. The ZIF board is a Rev B, but they should be the same. So we'll look here, and that is this chip. And this chip on this board is a 74LS 258. So I need to go get a 74 LS 258 to replace that. Be right back. Okay, here's a 74 LS 258. I could pop this into the Mini Pro, but let's go ahead and try it this way. Hey, actually, can you guys give me about 3 minutes? I need to take a break real quick. We are right at the 1 hour mark, so if you guys want to take a break, feel free. We'll give it another roughly 5 minutes, so you guys can go do what you need to do, grab another cup of coffee or beer, or whatever your libation of choice is, and we'll pick up in a few minutes. Yeah, Marcus and Maidolf, I'm right with you there. I do need to mow the lawn, and didn't get around to it today. I thought I was going to get out of it just by the fact that when I got up this morning it was raining, but unfortunately it stopped doing that, and it's dried out enough now that I could be out mowing. Well, if that's where you are, Rudy, congratulations to you. Maidolf, you do know that the British guy's native language is English, right? You're talking about his accent, and I agree with you. I'll, I guess I'm at a little bit of an advantage with the British folks though, because I've been watching British television since I was a little kid. Are You Being Served, Monty Python, Doctor Who, and over all that time, I've gotten to where I can understand most British accents, but I understand that a lot of people can't. There's plenty of accents, um, Middle Eastern, Asian, Eastern accents. I have a lot of trouble with. Yeah, Marcus, that's the best thing about it, is that moment when it finally all comes together, um, uh, and you get the result you're looking for, um, and realize that you've done that. You've made an accomplishment. Um, that little adrenaline burst when that happens is just wonderful. I'm sure we'll get to that on this one too. I don't think you're too far. Well, I know how far off we are because obviously I was the one that did the fault adding to this machine in the first place. So I know what's left. So we're pretty close. I think that's probably long enough. Everybody's probably back by now. So let's go ahead and put the CPU back, which oh, come on. I like the way the turn-to-pin sockets hold the chips, but sometimes they are very finicky about getting in there in the first place. So I believe the next thing someone mentioned was replacing the MOS-branded logic chip. And like I said, that was a 7709, and that replacement part is a 74LS258, and I got that here. So let's go ahead and pop that in. And before we test that out with the dead test, let's actually pop this 7709 into the Mini Pro. So here is the Mini Pro, and can't exactly show you. I don't have a camera pointing the right way, but I do have the 7709 seated in the TL866. So it was a 74LS258, and we will test. It fails. So that MOS logic chip is bad. Now let's see what happens with the dead test. We have power and we have video, and the dead test is in. And again, this is still the original dead test, not the STID one. What do we get? Hey, we've got some activity. Let's see where we get. Oh, got to the stack page before it failed. I'm actually confused here because I'm not sure what's actually causing that now. Unless there is bad RAM. It's possible there is some more bad RAM, as this dead test has gone back to flashing one flash. Let's see if we get that again. Look for consistency. This time it seems to be frozen on the 0 page. Huh. So we may actually have more bad RAM. Let's try the other dead test just to see what if it says anything different. So off, on, or off, off, on. Here's the STID dead test. 0 page bad, it says. So, we've still got more issues. All right, let's go back and check those address lines again and see if there's any difference. So y'all remember what it looked like before. Yeah, I turn the machine on. 1, 2, 3, 4, 5, 6, 7. There is data 0. And I'm still seeing some of those little half signals in there. Address 1. Yeah, there's still some low signals, but they're just under 4 volts. It should actually be plenty. Same thing there. And there. So we're still getting poor signals on the address bus. Yeah, it's all over the address bus, so it's nowhere specific. Let's see. The low half of the address bus, is it just the low half? Let me look at the upper half. No, that's solid high. That's solid. Those are 15 and 14. They're both solid high. 13, 12, 11. 12, 13, 14, 15 are solid high. Eleven, 10, 9, 8. So the upper half is, well, okay. There are the 257s, which handle the address bus, and let's see if we're getting anything weird over here. Yeah, those signals don't look great. I don't remember the pinout of the 257 off the top of my head, so I'm not exactly sure what I'm looking at. You guys can tell me what you think. Oh, that's ground. And that's VCC, so that should be 5 volts. It is. Those 2 pins I do remember. That looks good, whatever that is. Constant high. Mid-range signals. That's probably okay. High. Mid-range signals there. And again, that's probably okay. Those mid-range signals might be okay. They were getting, like I said, very close to 4 volts. And that's probably enough to indicate a logic high. Let's check this other one. That, I believe, is AEC. So those are the signals on the 257s. Anybody have any suggestions? No, you didn't have me look for hotspots. My fingers aren't the most sensitive things, but I do have this little infrared thermometer that I can use. So the RAM chips, that one is 33.3, that one's 33.2, that one is 33.8, that one is 34.4, a little higher but not too bad. That one is 31.4, 32.4, 34.1, 4.0, 34.9, again a little higher but not too bad. And our logic chips, 32.6, 31.2, 30.6, 31.1, 31.1, 30, 29.7, now that's our color RAM, 31.3, and 28.9. Just for reference, our VIC is at 39, a little over 40, 40.5, 41. Our PLA is at 34.3, and our CPU is at 31.3. Well, if we've got, as for the dead test, one dead test showing the 0 page is good and the other one showing it is bad, my thought for that would be that it was something in the logic, because that could be intermittent. Whereas a bad RAM chip is likely to be bad all the time, the logic could be intermittent and give different results different times. So my thought would be that we should stick with the logic chips. You guys can make any decision you want. I'll go wherever you want me to go with it. The IC next to the top row of the RAM on the left. So the 7406. That's reading 30.9 degrees. So no particular indication of a short. You want me to pull that one? Okay. I can pull that one and we can test it in the Mini Pro. The 7406 failed. Yeah. You're right. We have a bad 7406. And I will give you a little piece of information. I didn't make that fault. That's not one of the ones I intentionally put into the system. So let me go grab an 06. Wait. Oh, hang on. No. I did it again. Some of the chips in the Mini Pro have different versions, and the 7406 is one of them, and I just didn't notice it. So let's test this 7406. I tested it with the non-standard. We need to test it with the OCOD. Test it, and it passes. So that 7406 is not bad. So we'll go ahead and put that back in the board. Sorry about that, folks. I do forget that quite often. Okay, 7406 is back in. And where should we go from here? Well, Steve, the recap is this is one of the boards from my repairathon that I had repaired. It's the one you noted I had socketed almost everything in by the time I was done. So I introduced some errors into it, and we've been working on going through and finding all those errors. We found a blown fuse. We found, let's see, there was a MOS logic chip that was bad. The replacement, the 7709, which was the replacement for the 74LS 240 or 258. We had one bad RAM chip. We have verified that the VIC-2, the PLA, the CPU are all working. We've checked those in the ZIF machine, so they're fine. We have pulled SID, we pulled the ROMs, and we pulled the CIAs to see if we could get dead test working without those, but we're still getting I believe, well, at this point it's kind of weird. We're getting into dead test, so it's not giving us any flashing for memory errors, but then we get, in some cases it tells us 0 page bad, in some cases it locks up on 0 page, in some cases it does what it just did, which is 0 page good, and then when it goes to stack page it goes like this and then starts flashing as if it's got a memory error. So I think we're thinking that the problem is somewhere in the logic rather than in the RAM itself, because like I said, we've already found one bad RAM and changed it out. Our latest tests, we were looking at signals on the 257s, and then it was suggested that I look at the 7406, which also deals with addressing. We did looked at the addressing lines and data lines on the CPU. The data lines look pretty good. The addressing lines look pretty wonky across the board. So we were looking at everywhere that addressing was, which is what led us to the 257s and the 7406. We just pulled the 7406 and tested it in the Mini Pro. We have not pulled the 257s yet, and then of course we've got the 139, the 4066s. We've got quite a few chips left to look at. So that brings us up. Yeah, there was a time when it was giving us a scrambled screen. That seemed to be fixed when we replaced the MOS branded logic chip. It started giving us actual dead test. So, what do you guys want to do? Don suggests 257s. I'm willing to go there if that's what you guys want to look at. So let's pull and test them in the Mini Pro and see what we get. So 74, 257, and test. The first one tests good. So we'll slip that guy back in. And lift the second one. And the second one also tests good. So it's not the 257s. Without dead test, yes. There's dead test out. And it looks like we get just black screen without the dead test. Of course, that's going to be the case because we don't have the ROMs in. If you really want to see what it looks like, we can try putting the ROMs in. Of course, we don't know for sure they're good yet. I tell you what, why don't we test the ROMs? That way we can see if we can, get this ready to try a non-dead test with the ROMs in. So let's verify that the ROMs are good. I don't mean to be making suggestions for you guys, but I just think this is probably a good idea. So here's the ZIF machine back again. And we first turn it on and just make sure it's still working. Oh, there it is. Okay. Yeah, it's still working. So let's pull kernel first. And we're getting a black screen with kernel. Now, because I don't 100% trust the ZIF sockets, I'm going to reseat that, make sure we're firm, and I'm going to hold it down. Yep, black screen with kernel. So our kernel is not good. Okay, let's try basic. And the basic ROM is good. So let's try character. And the character ROM is good. Okay, so we do have a bad ROM I'll have to replace. So here's character. And basic. And let me grab a replacement kernel. And here's a pre-programmed EEPROM replacement for the kernel. Oh, hang on. This is a square pin. I never got around to fixing that. Let's see if we have a kernel. That's the round pin type. If you don't know this already, and it took me a while to get it through my thick head, if you're going to make these ROM adapters, you always want to use the round pin types. Oh, this is another square pin. Crap. Do I have a round pin one? No. You always want to use the round pins because then if you're going to go into a turn to pin socket, the square pins won't fit. Well, no. Let's see. What do I have? Character. Basic. Crap. All right, I know what I'm going to do just to get this testing done, so I don't have to build a new adapter. I'm going to go ahead and pull a ROM from one of the other boards. There we go. All right, that's kernel, and that's got the round pins, so this should work. All right, there we go. Now we can test without the dead test and see what we get. So we don't have the SID and we don't have the CIAs, but neither of those are required just for a basic boot. Without the CIAs, we won't get a cursor. And we definitely have corruption, but we have a partial boot. Neil, thanks for joining. If you're still there, yeah, um, glad you were able to join, and hope you enjoyed it. And tell your family hi. So, where do you guys want to go from here? We now have good verified ROMs in. We're still not. We still haven't gone back for the CIAs or the SID. The CPU works. The PLA works. The VIC-2 works. All the ROMs work. The RAM seems to be okay, and we've got an issue somewhere in the addressing. Now, we have tested the 7406 and both 74 LS257s. We have also replaced the 77 MOS 7709 with the correct replacement part 74 LS258. That leaves him, the two 4066s. Technically the timer, but that's working because we tested our reset and we were good there, so the timer is good. And we're still questionable on RAM. It's not definitely bad, but it's not definitely good either. Well, as for bad traces or solder blobs, unless one introduced itself spontaneously, those are unlikely. I know I didn't make any of those. I didn't want to do anything that could potentially damage the board when I created the faults, so I didn't do any of that. That's not a guarantee that they don't exist. We could check the back of the board just in case, like an errant bit of solder might have gotten onto it. I can check that. Let's see. Never a can of air when you need it. Oh, I know. Smart thing would be to get a brush and just brush it off. Okay. That should deal with any errant solder bits. See if that made any difference. Still testing without dead test. Nope, same issue. So, someone suggested bent pins. Well, that is a possibility. So, let me go ahead and remove the chips that I've removed previously. Now those are in pretty bad shape from when they were originally desoldered from the board, but they are intact and not bent. I could I suppose, just to be on the safe side. Oh, you know, there's a pin in that socket that I don't like the looks of. Let me see if I can fix it a little bit. Now, those pins in that socket all look good. Nothing's bent on the chip. But let's, just like I said, those pins, these chips were desoldered at one point. They're not perfect. So just out of curiosity's sake, let's go get a pair of 257s, fresh new ones, and put them in. Here are a couple of unused 257s. And just to be on the safe side, I'm going to check them in the Mini Pro. I'm not going to put it on the screen this time. I just want to make sure that they're good, even though they are brand new. I don't want to add extra new problems. Okay, both tested good. So we'll go ahead and install them and see if that makes any difference. Okay, check that. Nope, still got the same problem. Okay. Those weren't it. See, I also pulled this chip, so let's pull him. No bent pins. And the socket looks good. Still test normal in the Mini Pro. So let's go ahead and put him back. I also pulled this one. So again, no bent pins. Still the same problem. Okay. The other chips I have pulled were the CPU and no bent pins there. The socket looks good. The PLA. No bent pins on the PLA. And the VIC-2. No bent pins on the VIC-2. Now that socket could be an issue. It's an original Commodore socket and they aren't the best quality, but it seems to be working fine. Producing the video, well, mostly producing the video it should, I suppose. It could be. Tell you what, let me go ahead. I know I did this in the original Repairathon video, but it can't hurt to do it again. Another shot of deoxit. Nope, still bad. Okay. U25 and U13, you say U25 is him and U13 is him, and yes, those are the 257s, and not only they've been checked, but they've been, just for the sake of argument, I've gone ahead and actually replaced them with brand new ones. Try with dead test cartridge. Eight flashes. Of course, I don't remember what 8 flashes is. It is U21. So that's this guy here. Without that RAM chip, eight flashes still. So let's try another RAM chip. Okay. we're still stuck on 0 page. Other dead test. Crashes at 0 page. Yeah, that socket looks fine. You want me to look at U26? Okay. U26 is right here. U26. U26 is a hot contender. What is U26? Can't read anything on the back of this chip. Should know this. I think it's the 139. No. U26. Zimmers. 8-bit files. C64. Schematics. .373. 74 LS 373. 74LS373 going in. You may have just picked the right thing. I'll tell you what, every chip that I replaced to break this thing for this video or for this live, every one I marked on the bottom with an X. And this one, the one that I just pulled, no X. So it went bad during this process somewhere. A bit frustrating. Okay. Well, dead test seems to be running. So let's see what we get from regular diagnostics. Nope, we're still not good with regular diagnostics. Or did I put that? Maybe I put that wrong. Is that wrong? No. All right, what are we getting with nothing, with no cartridge? Still getting a corrupted screen. Oh, what's going on? Make the dead test. On, off, on, and ROM high. So dead test. Yeah, puppy. He gets a lot of loving. That's Oliver. Well, dead test is running through successfully. But when I go without dead test, I get a jumbled screen. Okay, I'm going to look at Ray Carlson's guide. See if I can find anything in here. Let me actually display it for you. See if I can find anything in here that looks like that. I'm going to actually zoom it a little larger. Kind of looks like this, which would be character ROM. So character ROM is a possibility. You know, let me check this. See if we got all these pins in right here. Ah, we have a pin out of place. Okay. That's why our character ROM isn't working. Good old Ray Carlson's guide. That thing is amazing. All right, let's see if we can get this in properly this time. Now let's see what we get. Still the same thing. What? I did not pop that pin out again. No, I didn't. Nope, nothing bent this time. Why didn't that work? All right, let's try another character ROM. Do have one of those somewhere. Yep. Okay, here's a different character ROM. See what this one does. Sorry. And it's still doing that. All right, now I'm confused. I'll tell you what, guys. We've hit another hour. So let's take another break. Everybody go do what you need to do. Get a fresh drink. I'm going to get a fresh drink. And be back in 10 minutes. How about that? All right, guys, I'm going to level with you. I introduced 4 faults into this machine. I put in a bad fuse. I put in a bad kernel ROM. I put in a bad RAM chip and the MOS branded logic. And we found all 4 of them, and yet the machine's still not working. So I'm going to give you guys the option at this point. I'm going to keep working on this, and I'm going to keep streaming. But I perfectly understand if any of you need to go and take care of other business. It's been over 2 hours already. So I understand if you want to leave. I obviously appreciate anyone who's going to stick with me. But I don't want to keep dragging you guys along and taking up all of your time when I'm pretty confused at this point. So for those of you who are going to leave, farewell and thank you. If you enjoyed what the time you had here, I'd appreciate a thumbs up. And this will be available for replay. So if you want to come back at a later time and watch and see if we ever did get it fixed, you're welcome to do that. And share it if you want to. Obviously, the more viewers and the more view time I get, the better. So I appreciate it. And for those of you who are going to leave, thank you very much. But let's get back to it. Paolo, I'm sorry. We've been working for 2 hours on this, and we haven't gotten very far yet. You're welcome to stick around. We're going to keep going, but I'm sure some people have other things to do. Yeah, the PLA. You know what? Marcus, I can do one thing just to be sure on the PLA. I do have one remaining GAL PLA, and this has been tested today in the ZIF machine, and it was working, so we'll give that a try. We get anything different with the GAL PLA? No, it's the same. So the PLA isn't the issue. Okay. Okay. At this point, since I don't know what's going on, before we go and recheck things that we've already checked, let's just go ahead and one by one replace the remaining logic ICs that haven't been replaced yet and see if any of them affect anything. So this guy hasn't been replaced yet today. This is, I think, a 139. Can't read it. Yeah, 74 LS 139. So let's get one of them. All right, any change? No change. All right. That's a this is an 08. So let's try a new 08. Nope, no difference. All right. Let's try some logic here. I'm looking at the schematics to see if I can figure out, since it seems to be a problem with character ROM, there should logically be a reason. The character ROM is here. Let's look at pin 20 on the character ROM is the chip select. Pin 20 on all the ROMs is the chip select. So let's look at the chip select signal on character ROM. That's gonna drive me crazy. All right. And 12, 13, 14, 15, 16, 17, 18, 19, pin 20. And that looks like good chip select on character ROM. All right, let's look at the data on character ROM, which is 9 through 17. 9. Those don't look great. There's something going on with the data lines. Yeah, there's some half signals, partial signals in there that don't look great. Huh. And that is all over the place. Oh, I lost my ground lead. There we go. That looks relatively normal. But now they're looking more normal. That's pin, wait a minute, 12, 11, 10. There's pin 9, which is data 0. And 10, data 1. And 11 is data 2. And 13 is, and 13 is data 3, data 4, data 5, data 6, data 7. Now the data, let's see what you guys have been saying. Bodge wires. I don't remember. I don't think I have any bodges on this one. No, this board, the back of this board is clean, bodge free. a second. This is deoxit from when I deoxited the VIC-2 socket. It's non-conductive, so it shouldn't have been causing any problems on the board. But just in case, we'll go ahead and dry it off. But yeah, no bodges. Just on the off chance, let's go ahead and retry now that I've dried off the deoxit. It shouldn't have made a difference because, like I said, deoxit is made to be non-conductive. But you never know. Nope, still the same thing. All right. Reading what you guys have been saying. Press down on the character ROM. Okay, try that. Don't think it's going to make a difference, but yep, same thing. Use a hammer. I think the character ROM is not sitting well in the socket. It's possible. Tried a couple of different character ROMs, but what I can do, just to play it safe or try this, is we can fit a second socket. Now, the only 24 pins I've got are the milled hole. If I had a leaf dual wipe or leaf socket, I would use that for this, but we can try this where we see the character ROM in this socket. We can even check our connectivity to make sure we're getting a good seating. Okay, all those are well seated in this socket, and now I can seat this in the socket on the board. And those milled pin sockets seat well together, so they should be fully connective, and we'll see if we get anything different. Same thing. So I don't think it's an issue of the character ROM not seating well in the socket. So I hate to say it, it's time to start tracing some traces, checking continuity, that things are getting where they belong. And for that, I am going to use BWAX Excellent 250407 Interactive Bomb. So we don't need this part. All right. So what I'm going to do here is you can pick any point on this board, click on it, and it'll show you. See, it'll show you where the traces go. So when I pick this pin on the character ROM, pin 13, it shows me it goes to a via under the CPU, and it goes to pins 13 of the other two ROMs. A lot of those are going to be common. Let's see, yeah, those are address lines. They should be common. Yeah, the address lines will be common among the three ROMs, and then the data lines will go separate places. So data were what, 9, 12, 11, 10, 9. Oh, missed. Data. What? No, wait a minute. Is that data or address? Data. Why are the data common? Okay. If the data are common, then we could have a conflict if we're getting chip selects at the same time. And that could be fighting. But that would be a problem with the PLA. '15, '16, and '17 on the PLA should never be low at the same time. You have to pardon me for a moment while I hook up my second channel probe. Let's see. 15, try 15 and 16. Okay, it looks like kernel and character are never low at the same time. Let's look at basic character. Well, basic is just constant high for some reason. Basic is never being selected. It doesn't get, it only gets selected at the very beginning of the boot up sequence. And then until you do something in basic, it stays unselected. So, but I'm not even seeing any activity on basic. Huh. You know what? We didn't check the kernel ROM. We just trusted that it worked. We need to test the kernel ROM. I know it worked when I built it. That doesn't mean it still works. Ziff machine. If the kernel isn't getting all the way through the boot up sequence, it would never reach basic, which would explain why I never saw any chip selects. So are we still working on the Ziff machine? Yes, we are. So kernel out. This kernel in. Kernel works. Okay. Without the kernel, we should get a black screen. And we do. Was it possible I had the kernel seeded wrong? Huh, nope, still the same problem. Oh, guys, I am confused. I'm reading your comments again. Rudy, connection issue with the character ROM. It's not in the socket. It could be on the board. I need to go back to tracing, like I said, using BWAX guide. BWAX interactive bomb. I need to go back to tracing these and seeing if they're getting where they need to go. So I will minimize this for you a bit so you can see what I'm doing. Let's hide that. And hide me. You don't need to see me. Tripod. And move this over here so you can watch what I'm doing. All right, so starting with pin 1 of character ROM. It should connect to pin 1 of the other 2 ROMs and a via over near the PLA. So back to multimeter, continuity. Sorry, that camera on the multimeter keeps getting interfered with by the multimeter leads. So I have to keep putting it back in place. It's not really loud enough for you to hear the continuity through my microphone, so I'll have to watch it on the screen there. All right, so pin 1 on the character ROM should go to pin 1. I'm not sure where it goes on that adapter, but it should go to pin 1 here. It does. And then it should go to this via, and it does. So pin 1 is good. And 2 again goes to pin 2 on the other ROM, and then goes to a via under the CPU, and I'm not sure where it goes from there. Let's see. Need to zoom the back side of the board up. Okay, the second via above pin 1 on the CPU it also should go to. Two to 2 here is good, and 2 to the second via above pin 1 on the CPU. Yep, goes there. Okay. And it should also go to pin 5 of the 373. And it does. Pin 1 also goes to pin 2 of the 373. And it does. Pin 3 goes to the other pin 3s. And then pin 3 goes to the other pin 3s, and it does. And pin 3 goes to here, and it does. Pin 4. Pin 4 to pin 4, and pin 4 to here. Yep. Pin 5. pin 5, and yeah. So pin 1, 2, 3, 4, 5 to pin 5, and pin 5, 1, 2, 3, 4, pin 5 to there. Yep. Pin 6. Pin 6 and that. Okay. And also the pin 6 there. Pin 7. And 8.
16.
Okay, guys. I have been. Oh, sorry. I have been through all the pins on the character ROM, and I have been through some of the pins on the VIC-2, and they seem to be connected where they're supposed to be connected. Let's see what you guys have been saying. Okay, back to a while ago, Rudy's Retro Intel said that he believes there is a problem with connection issue with the character ROM. I have just been through every pin on the character ROM, and they all connect to where they're supposed to go to. U17, the PLA, yes, it's been checked numerous times. Rudy, the flux capacitor has been checked and verified. I've just come back from 1972. Can I put back the CIAs to see if I get a cursor? I don't think we'll see a cursor because I don't think we can see a cursor, but I'll go ahead and do that for you. You only need the left CIA to get the keyboard working and get a cursor, so I'll put that one in. Again, I love these turn pin sockets, but they are finicky to get chips seated in. So there is the left CIA installed, and let's see what we get. I don't think I have, yeah. There we go. That back. Oh. Okay, now check it. We get some, I think that line that's moving through the screen is the cursor flashing. But no. And Rudy left. Oh, the link for BWAC's interactive bomb. Let me. I know I have that in my in some other videos description, but I'll give it to you here. It's on his it's linked from his GitHub page. But there's that. U14 is U14 is this guy here, and that is, hang on, that is the 74LS139. I know we replaced that, didn't we? I think I replaced that when we were looking at. I was just randomly replacing the chips we hadn't replaced yet, but I'll go ahead and do it again. It's not damaged or bent in any way, but I'll grab another 139. I'm pretty sure I've already done this, but we'll do it again. Doesn't hurt to try. No change. What else have you had to say? Let's see. Greg Smith, yeah, 3V is right. They have not been tested yet. So they're not known good working CIAs. And yes, I do have a ZIF to test them. We just haven't gotten that far yet. It wasn't necessary to test them and try to put them back until we had dead test working, which we only partially have. We seem to have dead test working, but it won't go beyond that. If I try to run the regular diagnostics with the ROMs in, but not the CIAs, we're getting this garbage type screen. This is without any diagnostics in, but if I put in this would be, let's see, switch to the regular diagnostics. This is with standard the enhanced standard diagnostics. We get that. So a partial display, which has nothing to do with the CIAs, but just to make you happy, I will pop in the other CIA. And there you go. Both CIAs are in, all the ROMs are in. The only thing that's out is the SID, and we're still not getting anything. So the CIAs are not the issue that we're having right now. And yes, it is true. They were not the original faults that I introduced to the machine. Those CIAs came from another machine that was working, so yes, they should be working. But we're trying to go through this methodically, and we hadn't gotten to the actual quote unquote test of the CIAs yet. If I had a board, Marcus, if I had a board that was faulty, we would have been looking at one that was just faulty. I wouldn't have made one that was intentionally faulty. I just didn't have any dead C64s at the time. Let's see. So yes, all connections to the character ROM checked out fine. I used BWAX 250407 interactive bomb to see visually where they connected to, and I got connectivity when I checked. I also checked. I don't know. Someone probably saw me. I also checked pin to pin on the character ROM to make sure none of the pins were shorted to each other. That, of course, doesn't rule out shorts other places on the board, but wow. Well, I'm just looking at what we're seeing on the screen right now. You can see that it's actually passing a bunch of the tests, but we're just not visually able to see it. It's got to be something to do with character ROM. It's got to be something to do with character ROM's connection to the VIC-2. Now, the VIC-2, there are chips, or a chip or chips, that separate the data bus and the address bus. How does that work? The VIC and the CPU cannot talk to memory at the same time. There's a signal called AEC that tells, I think the CPU generates, the CPU generates it, and the VIC-2 reads it. Where is it on the VIC-2? Pin 16 on the VIC-2 is pin 5 on the CPU. 1, 2, 3, 4. Pin 5 is AEC on the CPU, and pin 16, 20, 19, 18, 17, 16. And there's no connectivity between AEC. Okay. So, pin 20, 19, 18, 17, 16. Pin 16, 1, 2, 3, 20, 19, 18, 17. Pin 16 goes to a via out here. What? 16 goes there. What? Oh. So pin 16 goes here. Yep. And then that goes there. Alright, that signal looked like it was good. AEC looks good there. And it looks good there. Oh boy. Yeah, I broke the computer as much for myself as I did for you guys. It gives me something to do. Thanks, Steve. You do seem to have a point. Let me try something. Ow, that's hot. No, burn my fingers. Try. No, that didn't do anything. I'm desperate at this point. This is the character ROM from the ZIF machine. And it's possible that both of those character ROMs that I have here are bad, even though they're marked good. Let's see. No, that's not it. I don't know what to do at this point. Yeah, I do. I'm going to call it a day. You guys have been extremely patient with me, and I can only apologize. But I don't think I'm going to get anywhere today. I'm going to have to come at this with fresh eyes on another occasion. I really had the best intentions with this video, but it just didn't work out. So, again, I apologize that we didn't finish this. I really thought it would be simpler. You know, I knew what the problems were that I introduced. I told you I put in a blown fuse, I put in a bad kernel ROM, I put in a bad RAM, and I put in a bad MOS logic chip, and that's all I did to it. Of course, I did take out all the um, large socketed chips, mostly because I had already glued heat sinks to them. They would, that would have been a good indicator of, heat sink, heat sink, heat sink, heat sink, heat sink, heat sink, no heat sink. You would have suspected the kernel, so I couldn't do that. But all these other chips didn't get moved, didn't get touched. I pulled this one to put in the bad MOS logic chip, and I pulled the one RAM chip. It was this one. And beyond that, I didn't touch any of the other logic chips, so I don't know why there would be issues with them now. I'm just going to have to keep fighting with this, but I'm not going to take up any more of your guys' time. You've been more than generous with your with jumping in and helping and giving suggestions, and I very much appreciate all that. Oh, there was actually a fifth fault ish. The SID that was in here, this is actually a marginal SID. It works to an extent, but it doesn't sound very good. So we would have found that at the end. That was number 5. But everything else in here was, beyond those 5 was supposed to be good. So I'll keep fighting with it, and if you enjoyed the video, shoot it a thumbs up. I'd appreciate it. If you hated every minute of it, and I could understand why you might, then you know what to do there too. I think you all are already subscribers, but I'll mention this for any that might not be. If you haven't subscribed, please go ahead and do so. Click the notification bell so you get notified when I post new videos. And if you get a chance, go over to my friends' channels. Some of them have been on here today. Retro for You, 8-Bit Retro Refix, Joseph's Retro Bits. I never know how to say his name. Sorry, Joseph. And Captain Commodore. Their information will be eventually in the description below. And that'll do it for today. I appreciate your time, and I'm sorry again that we didn't have a completion, didn't get that adrenaline rush of having completed something that we've been working on. But I'll keep you updated, and stay safe, stay well, have a great week, and we'll talk to you later. Bye.